through a couple of slides with these guys as the advanced class continues with their practicals. And we're just gonna actually continue from where we left, although we're gonna sort of take a different tangent. But overall, it's the same topic really, which is around virtual environments. And what I'm going to do this afternoon is to introduce you to yet another virtual environment. And something maybe you've heard about, containers. So just as a recap, we went through Coda, which is a really nice virtual environment that runs natively on your machine, right? And if you remember, we had different installers, so Windows, Mac OS, and Linux, and Coda can support different architectures depending on the chip that is on your computer. And again, Coda is really great for Python and Python environment and works really great. But there are some issues with Coda and virtual environments. I've not touched about another yet a virtual environment called the Python virtual environment, or Pythoness. I think some people like it that way. And I'm just gonna talk a bit on another technology called containerization, right? Yes, please. No, no, they don't do the same thing. What she's asking is whether Homebrew is the same as Coda and whether they do the same thing. And I said they don't do the same thing. Okay? And it's important because a Homebrew is a package manager that was initially written for managing applications on Mac OS platforms. Okay? Coda is more than a package manager. Yeah? So it is a virtual environment, and initially it came with a package manager that was integrated with it until they pulled it out. And that's what Mamba actually does. Okay, yes, yes. So technically speaking, Coda is a package manager and a virtual environment manager. It's like two things in the same, built together, and offering that facility. In the sense that you create a virtual environment and then you can install packages on that virtual environment. Okay? In some other instances, you get package managers that will just install things, but they will not take care of your environment. That's what Homebrew does. So Homebrew is a package manager. It will install your packages in the user bin or bin or where you ask it to, and then it will modify the path. But it is not a virtual. It's not an environment manager. So you cannot have multiple instances of Homebrew. And Homebrew, you cannot install or have multiple virtual environments in Homebrew. Okay? So it's simply a package manager. And I don't know whether you can actually install Homebrew on top of Coda. I don't think so. Yeah, because of the dependencies. Yeah. So just back to containerization. So if we are familiar with the shipping industry and you want to ferry stuff across the oceans, I think initially, you just have your package and, you give it to the merchants and, they would find a way to wrap it around and ferry it. Okay? But then it becomes difficult when you offload those items at a port of exit or port of entry. Because then you got to know which package came from where and who was the merchant and who is the recipient. But more than that, I think it becomes really difficult to know how much weight you're going to carry on the ship. Okay, so the shipping industry came with a concept of containers, right? And it just turns out that these containers can be packaged and the ship will deliver them. And each of those containers will have a label, they'll have a name, and it's just easier to manage. Okay? And each of those is like that ship can carry loads of stuff in each of those containers, but it's a single ship. Okay, so I'm not sure whether containerization in the computing sense is really borrowing from this analogy in as far as packaging multiple things, multiple environments, and delivering them to a single destination or to multiple destinations. Okay, and it turns out that what we're trying to do really, particularly with the virtual environments, is a form of creating, if you like to look at them like distinct computing environments. And Coda goes only as far as it can go to creating those environments. If I was on a Macintosh and I wanted to run software on Ubuntu, it may be that a bioinformatician has created this particular tooling, but it only need to run on an Ubuntu machine. What do I do? Okay, and I'm on a Windows machine. Can I run a Linux machine, a virtual machine on my Windows platform? Okay, so this goes a little bit high up to try to deliver that target. Again, this is from Phil. If you remember about the evergreen that blocked the Suez Canal, and the thing is just to say, it doesn't always work, and these Docker and platforms, they can jam, and if that happens, it's nothing you can do on your system. But then you can just uninstall the thing and get back again. Okay. So just to recap, the containers is just a mechanism of creating a real nice virtual isolation of your computing environment into what sometimes you call a sandbox, if you like. And you can create these sandboxes. And before that, we were all on Coda. It's now possible to do that and create multiple operating systems or run multiple operating systems on your current operating system. And before this technology came on, we had virtual machines, right? So, and the virtual machine was a way to abstract your computing in a way that you can share resources, your CPU, your memory, your disk manager, and so on and so forth. Okay, but it wasn't very optimal because as you're trying to do that, the resources required to install a virtual machine, to run a virtual machine, was a bit difficult. And it came around that I think with Unix systems, got a process called systemd that you can take advantage of to create these containers. So in a nutshell, all I want to say is that what we are going to do is see another way to abstract virtual environments and into sandboxes. Okay, and the reason for this, as the analogy on containers, is that it's much more portable. Okay, and it's consistent and quick to deploy. So once you create a Docker image, you can share that. You can put it up on the internet somewhere, and people can download and have exactly the same environment, irrespective of the operating system that environment has been created on. Okay, because there are advantages in running certain tools using specific diastros or specific versions of operating systems. Okay, and therefore, I did talk about virtual machines rather, and this is how it used to run. I don't know that Masita is here. And, can ask more questions about it. But then you get your hardware, which is the actual box on which your systems is running. Yes, please.
Sorry, I'm trying to figure out what the main
Yeah, by the end of this, hopefully, you should be able to tell the difference. I'll try to see if I can make the difference. So I'm just taking a step back to what then was virtual environments or virtual machines as they were before Docker technology, Singularity, and the other guys came on. So at the end of the day, at the base, even when you are speaking about these virtual environments, is that you got the hardware. That's a computer on which your operating system is based on. Okay, and on it you got an Intel chip, or you got an ARM chip, or AMD chip, whatever it is. Okay, but it is hardware. And on top of the hardware, you usually have an operating system, your host OS. Okay. In my case, I'm running on a proprietary hardware by a company called Apple that integrates their operating system with their specific hardware, which is good and bad. Okay. And this machine here is a much more general hardware that is running an Ubuntu Windows. Is it? Yeah, it's running Windows operating system as the host. But you can install any operating system on that hardware. I can install Linux, and I can install whatever version of Linux that I want, and I can install any other operating system on that hardware. A little bit more difficult with this hardware because it's proprietary, but there are ways to get around it. Okay. And therefore, what then tends to happen is that you have another layer of software that you can install on the host OS, the so-called hypervisor, that allows you to abstract the hardware resources, okay? And on it, then you got virtual machines, and on each of these virtual machines, you can run different applications or different programs, okay? And that's basically how the virtual environments work. And in a sense, is sort of the way we want to get around with our containers is that we want to abstract the hardware, separate it completely, and allow multiple virtual environments to run, or operating system to run on our base environment or software. Okay? So the way to do it here is that rather than, so if you see on this picture here, the old way of doing it or the alternative way of doing it is that we got our hardware, we got our host OS, and then we got a hypervisor, which is a specific software that allows you to do those abstractions. And some clever people come around and they say, well, as long as you get a server that runs on some hardware down here, an operating system, our Docker engine, we're going to be talking about Docker today, will run on top of the operating system, abstract the server resources, and you can run different operating systems on top of your operating system. Yeah? So that is different from Coda in the sense that you cannot run different operating systems on your Coda environment. Okay? You have to run it on your host operating system. Okay? Yeah? Which comes with some advantages and disadvantages. Okay? So each of these is a container, if you like. Okay? And our ship here is carrying each of these containers. Okay? So our operating system, our Docker engine, the Docker engine is allowing us to run multiple applications, to run multiple operating systems on our hardware. And we can abstract this in its form of a file, and it's portable in the sense that I can create a Docker file that can allow you to replicate this interface, if you like, or environment on another computing server. And that means that whatever I install here is completely reproducible, and it always runs in the same way as I specified, okay? Using the same build chain. Okay? So the containerization is free and open source that allows you to build, deploy, manage all this infrastructure. And then you got a company called Docker Incorporated that is actually for-profit, I think, that helps set this up for companies, and I think that's how they make their business. Which reminds me, there's an interesting article that I read for those who are interested, whether that is a good model or not, but sort of not so relevant for this course. Yeah. Yeah, so essentially, the platform will allow you to build, deploy, and manage your containers. And you've got Docker, which Incorporated, which is a company behind the technology. So they found a way to make money and give open source tools. So push technology ahead. Okay. So if you're dealing with this technology, you'll hear a lot about images. You hear about Docker Hub. you hear about the daemon and the client. Okay, so the images is just what I've illustrated. You can have an Ubuntu image, you can have a Fedora image, whatever it is, and then Docker Hub, which is sort of a repository where people put their images, and you can pull those images, particular applications, and run them. And then you got the Docker daemon, which is the, the the main sort of engine, really, the core software that is allowing and abstracting your operating system, your hardware resources to allow different images to run, and the Docker client, which can be either, depending on the scale, it can either be a particular virtual machine computer, or it can be any of those images. Okay, and often this is how sort of the architecture for Docker will look like. You've got the registry running different whole operating systems, containers, if you like, distributions, and so on. And then you got your images, which you can abstract into containers. All this is taken care of by the Docker daemon, which is the main control file or software that can allow you to build new containers, pull from the registry, and then allow you to run your software using the Docker run, as we'll quickly see. And all this is happening on the client side, okay? Which is like, if you like, the computer. Once you install it, your computer sort of assumes this client, and then you got the main Docker daemon running, and then you got a registry that will live somewhere on the internet, okay? And sometimes, depending on organizations, they can have these registries running locally within the HPCs, assuming that you mean the main bioinformatician, you're supporting bacterial genomics, or supporting virus genomics, you're supporting human genetics, and so many other things. And you may have core workflows built for different streams that can all work together, and therefore you can create a local registry to allow people to pull or from that local registry. And you can publish that onto the internet, either through Docker Hub or other registries that allow you and other people to pull from your that architecture. Okay, so just as a way of recap, we got Coda, right? Open source package management system environment that can run on Windows, Mac OS, Linux. Install and update your packages and dependencies. Largely initially created for Python, but adopted to support a wide range of other tools, right? And Docker is this concept we've come around with, which is containerization, that can allow you to experiment by building these container-based applications. And when you're working within sort of Docker, it almost feels like you are running particular operating systems or containers. Well, they are containers, but once you log in, as you'll see shortly, you can be on a Windows system and absolutely pull in a Docker image that is Linux-based and allow you to run this, okay? As we'll see. So not talk very much about Singularity, but Singularity is a container technology that competes with Docker, but solves a slightly different problem. Because Docker is really successful, but then it turns out that with Singularity, you can do a lot more, particularly within HPCs. Yeah? And therefore, I think we'll talk about that maybe tomorrow. But Singularity runs on HPCs, and you can do a lot more than you can do with Docker. Okay, we'll come down to that. Yeah, so I've just said that, but I'll talk a little bit more about Singularity maybe tomorrow or the day after. Okay, so I had a small practical on that we can go through, and I think I've posted it up here. Okay, I'll try and blow this a bit. So just as a way to should have blown this a bit. And because sometimes installing this can be a bit difficult, I asked Edwin to set Docker up for us. I wanted to increase the font size, but I don't know how to do that. Okay, I'll do that later. Okay. And the idea here is to experiment with Docker. So Docker is installed on your client, and you can try that by coming here and maybe type in Docker. Okay, and if you do that, if your Docker is installed, you see all the commands and sub-commands that you can run. We're not gonna use all of them, yeah, but we will see a few of them. Okay, quite a number of them. I think for now we're gonna get more familiar with the Docker run command, which we'll be running through. Okay, and if that is successful, on the internet there is an interesting image called VisiBox that we can pull. Okay, which is a set of tools that you can run and use. We're gonna try and pull that image, right? And we can run a couple of commands on it. But more important is the ability to know what is running on our environment, which is a set of commands here. Again, for those of us who are familiar with Bash, I think we're also familiar with the PS command. Yeah, for processes, if you want to know what processes are running. It turns out that it's quite an important command if you are with Docker, and you can look up and look at the images that you're running and the processes that are running. So I've just typed a couple of commands here just for us to get familiar with Docker. And for a practical course, I wanted us to download this image from Nexttrain, which is the Nextglade tool that you can use to work with SARS-CoV sequences and run a couple of commands, alignments, and so on. I've posted the documentation here, and you can try run it. I'll put some more. I'll update that a little bit, but I wanted us to get a little bit more familiar with this. Okay, so I'm just gonna clear my thing, and I'm gonna say Docker pull VisiBox. Okay. So the question, yes. So the question is, why do they call them images? Anyone who wants to look at that? Why are we calling these things images? There's a particular moniker in computer science which says two things that are difficult in computing. One of them is naming things. Naming variables, what do you call it? So it comes from, so technically, historically, different diasporas have been named images. So whether it's, I would say, for example, Linux image and so on. And I don't know exactly where it comes from, but people historically call them images, right? Or diasporas, if you like. So I think it's just this idea that just like a picture, it's just an image. Internally has a set of instructions on how to get, and you can copy it around. So I think the word image sort of fits that moniker. But I'll try and Google around and see why they exactly call it images. I don't know. So this is running on your Linux environment. So this is separate. So if you actually look, yeah. So if you look, actually, I've got my base on here, but I'm running Docker, which is slightly separate. So I got the Docker daemon, and that is not dependent at all on Poda Minicoda. It doesn't matter. Doesn't matter. As long as you got Docker installed, it will run, and it has its own storage and completely separated environment. Okay. So what I've done here is that I've pulled in this image called VisiBox, and let me see if we can. I had a proper tutorial here on VisiBox here, so you can play around with this. And so I pulled this material here. So this is the command that we just ran, okay? And the thing about, I think I've posted this on the, I don't know whether I've posted this on the, I just post this here, okay? You can link on it and head here. And the good thing with this tutorial is that it does try and explain to you what is happening with each of these commands. Yeah. So the next step is to run Docker images that can allow you to see what is installed or how many images you have. So if you come down here, you can run images, and you can see that my environment has a number of images. Okay. I'm running in. Some of them installed quite a long time ago, set up a long time ago, and some that are more newer. You got this latest, and you got the checksum. We did talk a little bit about that and what the size of those images are. So the largest one is this 1.9 MB. And oh, we've got another one here on Blast, which is quite a couple of GBs. Nearly 2 GBs, huge. Okay. The Docker run command allows you to initiate and run that particular image, or call it if you like. So let's try and do that, and nothing will happen really. We can see any output out of this VisiBox image, right? But we can ask it to give us some output by running an actual command, because this is a POSIX compliant terminal or box. So by doing run VisiBox and then giving it an echo command, yeah, and we're just gonna say hello from the other side. Okay. And it actually executes that. So this is really nice if you're like Windows, where you don't expect to find the echo command. And now you actually are on a POSIX compliant terminal, so to speak. And my other one that I can do, if you remember, we ran this command to know what the architecture of our system is. So I'm going to run that through Docker, but if I run architect on my base command, my base operating system, I'm on i386, but the Docker is x86-64 architecture. Okay? Because that image is created on base 86-64, right? So what you see is that I'm executing completely different architectures on the same CPU. Yeah, different hardware, or and that's really nice. That's really can be really powerful. Okay, and at a fraction of the operating cost and resources. Okay. So VisiBox is an image created that contains a lot of Unix tooling. Yeah, you can Google it, and actually, because I expected somebody to ask that, I did actually look at it over here. Okay. Yeah. So it has all the tooling for POSIX compliant. Or am I using tools? Okay. So it's a software suite that provides Unix utilities in a single executable file. So I'm just using it for example purposes. Okay. And it's POSIX compliant. Um, has a bit of history when it was created by Bruce Perens and so on and so forth. I'm not going to go into those details, but essentially it is a Linux terminal. Okay, and I only do it because it's easy to do and it's not heavy. It's only if you remember that command that we ran previously, relatively it's 4.86 MB huge. I could download an Ubuntu machine, but that's relatively large, although not that much. So I got also an Ubuntu machine there, which I think if I did the same here, assuming that I still have this running, yeah. So I'm just switching between operating systems for the purpose of this tutorial. Yes, that I pulled. This. Exactly. Yes. So almost all standard Linux distros or versions, if you like, are already available on Docker. So if, for example, I was running a bioinformatics tool, and let's say that this tool only runs in this environment or in this image or operating system, it simply means that I can set it up, okay, and have it run on that image, okay. Yeah, and that's important, okay. Yeah.